Hello, everyone, and welcome to our lesson on lighting efficiency. My name is Roger Williams, an instructor with Solar Energy International. In this lesson, we're going to compare the energy requirements of a few different light bulb types, and we're going to do a quick calculation where we can determine the lighting loads. So let's go ahead and get started. Now, when we're talking about lighting efficiency, we're really going to compare these two different bulbs, LEDs and CFLs, to the traditional incandescent light bulb. That's the light bulb that we all had for a very long time, and it's quite an inefficient light bulb. It's said that maybe only 10% of the energy that goes into an incandescent light bulb is used to create light. The rest of that, the other 90%, goes to producing heat. So that's not a very efficient light. What we're going to do now is look at the more recent developments in light bulb technology, and I'm talking about LEDs and CFLs. So the LED bulb, or light emitting diodes, when we compare that to a 60-watt incandescent light bulb, it's much more efficient. These required around 75 to 80% less energy than the comparable incandescent bulb. LED bulbs can last up to 25 times longer than incandescent bulbs, and they can also produce the same light intensity or lumens. All the light bulbs, no matter what type, there's a certain power requirement in watts, and there's also the amount of lumens that specific bulb would create. Another thing about LEDs is they're quite versatile, they are very durable, they work well in cold temperatures, and they turn on instantly. We'll see when we compare them with CFLs that CFLs don't necessarily have those same attributes. Probably the one issue that I can think of with LEDs is that you get what you pay for. The quality of some of them is not very good, but certainly high quality LEDs can require much less energy. They can last quite a bit longer than incandescent bulbs, and they can provide you very high quality light. Now let's look at the compact fluorescent bulb, or the CFL. Again, we're going to compare it to a 60-watt incandescent light bulb. The CFL would use about up to 75% less energy. Again, it depends on the quality of the bulb. CFLs typically last longer, much longer than incandescent bulbs, up to 10 times longer, again, while also producing the same amount of light or lumens. Now, CFLs have a couple of bad attributes, I would say. One is they contain a small amount of mercury. When you have a CFL that is no longer working, you have to dispose of it properly. And we mentioned with LEDs that they work well in cold temperatures. And CFLs often have to, quote, warm up. Right? You may have experienced that when you are using a CFL light bulb, that when you turn it on, it's not very bright. It might actually take a while for it to, quote, warm up. That's because of the way the compact fluorescent lamp inside the light bulb works. But both of these technologies, LED bulbs or CFLs, are much more efficient than the traditional incandescent light bulb. And I would say CFLs and LEDs are the new tradition, right? They're much more efficient, and they give us the same quality of light, or they can give us the same quality of light as incandescents. Again, both LEDs and CFLs, you get what you pay for. If you buy high quality bulbs, you're going to be impressed with the light and the longevity. Now we'll get into some comparison, right, of the energy use of the different light bulbs. So here we have a traditional incandescent light bulb. It's quite a thing of beauty, really, but let's look at its daily energy use. So in this example, we're going to have a 75-watt incandescent bulb. Let's say there's 10 of these in my home, and I use them for 2.5 hours per day. We multiply all that together, we get 1,875 watt hours a day, or when we convert that to kilowatt hours, we see about 1.9 kilowatt hours a day for my lighting load of these 10 75-watt incandescent bulbs. But now let's do an energy savings analysis where we change those incandescent bulbs out with LED bulbs that produce the same amount of lumens or light intensity. So we're going to start off with our 10 75-watt bulbs that run for 2.5 hours a day. We're going to replace them with 10 15-watt LED bulbs. So that's a big power savings, right? That LED bulb at 15 watts requires 1/5 of the power that incandescent bulb does. So our 10 15-watt bulbs are replacing the incandescent bulbs. Then we can look at the energy comparison. We multiply those out. Again, we see the 1,875 watt hours a day with the incandescents, and we see the LEDs are going to only require 375 watt hours a day, and in fact, that's 1/5 the energy comparison. When we look at the energy savings, we see we're saving 1,500 watt hours a day, or 1.5 kilowatt hours per day. And over a year, that's almost 550 kilowatt hours saved just by replacing those 10 light bulbs. So that is a tremendous increase in efficiency where we're getting the same amount of light by using less energy. And that energy savings is over 0.5 megawatt hour a year for those of you who talk in megawatt hours. And that's going to wrap up our quick lesson on lighting efficiency. We talked about how it's possible to produce the same amount of light using less power. That is energy efficiency. We also saw how small changes in power use can add up over time. We replaced our 75-watt bulbs with 15-watt LEDs, but over time, that's saved us over 500 kilowatt hours a year. That's a decent energy savings. Well, I hope you're all running out to buy new, more energy efficient light bulbs, and let us know how that goes on your electricity bill. Talk to you soon. Thanks.